I call this 4-3b, even though it's like part of 4-3a and 4-3b all together.
Can you tell us though when we hit like actual 4-3b?
Yeah.
Because the way your numbers are getting mixed up.
I know, right?
So.
Okay. We're going to talk more about the reference angle. No, I'll fix it. I'll fix it so it's not messed up. No, well, it all goes together. It'll be fine. Yeah, it actually goes really nicely with this stuff. Okay. So here we go. Oh, I was watching, have you been watching preliminary Olympic stuff?
Yeah.
Yeah, I was watching these guys who were on skis.
Did you watch figure skating?
No, that's not good. I was watching these guys who are on skis, and then they do these jumps. And like, oh, we did a 720. And I thought about you guys.
Wow.
Because remember, we do angles that are like 720.
You know the first
so it's possible.
Did you see the...
Yeah. Ooh, let me pause this. We have a reference angle, and we already drew the reference angle before. This is what we're going to do, though, now. We're going to let theta be an angle that's in standard position. Standard position. And the point xy is going to be on the terminal side of theta. On the terminal side of theta. Okay? Yeah? So for example, let's say we have this point right here in quadrant 2. Doesn't have to be quadrant 2. This is just an example. And let's say that that is the point xy. And we're going to say that that point is on the terminal side of theta. So we've already done this part. We draw this, and this angle here is theta. Okay? Now, what we do is we are going to then drop a perpendicular to the x-axis. We're going to call this theta prime, which is our reference angle. We did this, yes.
So where is it?
Question.
Because we need it for the next thing. Yeah.
Is the prime, is that always touching 0, 0?
Yes, always.
Okay.
Oh, that was outside. Oh, is that me? Oh, shoot. Okay. All right, so now what's going to happen is you're going to have that triangle there. We did already talk about that, but we didn't label the hypotenuse. We're going to call this triangle. This side is x, because that's the distance on the x-axis. This side is y over here. It's our right angle, and we call the hypotenuse r. And r is equal to the distance from the origin out to that point right there. R is always equal to the square root of x squared plus y squared.
Is that the distance formula?
Yeah, it is the distance formula in the sense that, yeah, you're taking the distance from the point xy to 0, 0, so you'd go x minus 0 squared plus y minus 0 squared. It is the distance formula. Okay, so now we know that the sine of theta is going to be the same thing as the sine of theta prime. So the sine of theta is going to be y over r. And the cosecant of theta is going to be the reciprocal, which is r over y, as long as y doesn't equal 0. If y is equal to 0, then cosecant is going to be undefined. Then we can say that the cosine of theta is going to be adjacent over hypotenuse, x over r. And secant of theta is r over x, as long as x is not 0, because x can be 0. If I gave you a point like 0, 5, then secant would be undefined. And then finally, tangent of theta is TOA, opposite y over x, as long as x is not 0. So tangent can be undefined in certain parts too. And then cotangent is the reciprocal, which is x over y, as long as y is not equal to 0. Okay, so that's the type of thing I did not go over on Friday. And then I also didn't go over this next part, which would have been very helpful in those problems. What were they, like 13 through something? 13 through 20, all of those? Okay. All right, so if you have a quadrant, your Cartesian plane, and you went and you did your angle to quadrants 1, 2, 3, 4, okay, all of those things. And you use the reference angle, blah, blah, blah. Well, certain trig functions are going to be positive in certain quadrants, okay? So this is a little way to remember this. All of your trig functions are positive in quadrant 1, all of them. So you take the sine of any angle from 0 to 90, or 0 to pi over 2. 0 to pi over 2, you're in quadrant 1, okay? That's what they were asking you for in that one. In quadrant 2, which is pi over 2 to pi, sine and cosecant are positive over here, okay? The other 4 are going to be negative in quadrant 2. And that should make sense, right? Because the y value is positive in quadrant 2, but x is negative. So look at all these that have y's, and they're going to be positive. In quadrant 3, tangent, and cotangent, those are going to be positive from pi to 3 pi over 2. And then from 3 pi over 2, what's left? Cosine and secant are going to be positive over here in quadrant 4 from 3 pi over 2 to 2 pi. Now here's the way that we remember this, okay? You know how like you had your north, east, southwest, never eat soggy watermelons or whatever you guys say? What we do here is we say, all saints trust Christ.
Wow.
That's the Christian way to say it,
What
of
are the other
course.
ones then?
If you went to a public school down the street, you would learn that all students take calculus, or all students try cocaine. There's lots of things. Yeah. All sisters take clothes. I've heard all kinds of things, right? So, but, at Valley Christian, we like to say, all saints trust Christ.
All strippers take cats.
Ew, no! Did you hear that back there? Yeah, this is pretty good. I haven't heard that one. That was really good. So true, too. Okay, true story. Anyways, but if you remember that, that's a good way to remember it. I had to present one time in my college my class in college was like a math teacher class, and I had a trig problem, and I said, yeah, because we all know that all saints trust Christ, so we know that this is, and the teacher stopped me. He's like, what? And I'm like, oh. He goes, oh yeah, that's right, you went to Valley Christian, didn't you? And I'm like, yeah, it was at Cal State Fullerton, but he was a Christian, so he's a nice man. Anyways, okay, so if I ask you, so let's look at some of those homework problems that I assigned that maybe I shouldn't have, like number 13. Number 13 in your homework, it says, state the sign plus or minus for the sine of t, the cosine of t, and the tangent of t for the values in the given interval. So 13, they tell you that the given interval is 0 to pi over 2. What they're asking you to do is tell me, what the sign is when you take the sine of an angle in the first quadrant. 0 to pi over 2 simply means quadrant 1. Now, why couldn't they just say quadrant 1? I don't know. I would have.
They like to make life difficult.
They do. All right, but we know these answers now. So is sine positive or negative from 0 to pi over 2? Positive. They're all positive, right? All of them are positive in quadrant 1. So then question 14 asks you, okay, which ones are positive, or what are the signs from pi over 2 to pi? So question 14 would be positive for sine, but negative for the other ones. Okay? So you just have to remember, all saints trust Christ, or whatever you have, and know that sine and cosecant go together because they're reciprocals. Okay? If sine is equal to 1/2, positive 1/2, then cosecant is going to be positive 2. They'll be the same sign. Does that help you a little bit when you get to those? Okay, yeah. Sorry about that. It even says on my paper, do not skip. I must have run out of time.
You did.
I did.
Oh, it says do not skip. Okay, guys, bye.
I think you had like a C left over from 4.3.
Yes, that was it. That was it. Okay, so now let's do the new stuff today, okay? And what we're going to do, I'll even write 4.3b here, or 4.3b. We're going to learn how to evaluate the sine, evaluate all of our trig functions, and we're going to do this in a couple of ways. One way we're going to do this is we're going to use something called the unit circle, which we're going to learn tomorrow. Okay, and that's my favorite way to evaluate a trig. But the book also wants you to know using your special triangles. Do you remember your special triangles? Yeah, 30, 60, 90, and 45, 45, 90. Okay, they want you to do it that way, but they want you to do that in any quadrant. Okay, so let me show you an example. So we're going to evaluate by hand. Number 1. Evaluate. And these need to be exact answers, so we're going to have radicals in them. Okay? So we're going to evaluate the 6 trig functions. 6 trig functions of 315 degrees. So in other words, I want to find the sine of 315, the cosine of 315, so on and so forth. So let's go ahead and it's nice to draw a picture a lot of times. So we're going to go to where 315 degrees is. So we're going to be over here in quadrant 4. Okay? So that's 315. How much more is it to go all the way around the full circle? 45. Perfect. So go ahead and drop a perpendicular, and we know that this little angle in here is 45 degrees. And so when we go ahead and we want to take the sine of 315 degrees, it's going to equal the sine of this reference angle in here. It's going to equal the sine, I'll call it theta prime. Okay? It doesn't necessarily equal the sine of 45, but it equals the sine of 45 in quadrant 4. That's the important part. So let's go ahead and set up our triangle here. We are in quadrant 4, so our x and y's aren't going to be necessarily positive, of course, right? So across from 45, this is going to be -1. See how we're down here? We dip down into the negative values, and then this would be +1. And the hypotenuse would be the square root of 1 squared plus -1 squared, which is rad 2. And everybody knows their 45, 45, 90 triangle. And now we evaluate, okay? Couple ways you can do this. You can do it like this, or you can just evaluate the sine of 45, cosine of 45, and then remember which quadrant you're in, and then put their signs accordingly. You can do it that way too. All right, so let's do it. What is the sine of 315? Sine would be SOHCAHTOA, so opposite over hypotenuse, -1 over rad 2. Apparently your book is fine with that, I guess. I just can't. Anyways, I can't even. All right, so then cosecant of 315 would be the reciprocal of that, which would be -rad 2. And shouldn't sine and cosecant be negative in quadrant 4? Yes, because only cosine and its reciprocal are positive in quadrant 4. So here comes cosine. Cosine of 315 is really just like taking the cosine of 45 degrees, which would be adjacent over hypotenuse, 1 over rad 2. If you want to, I will not mark you wrong, okay? I just personally, I can't do it. And then secant of 315 would be just simply rad 2. Tangent of 315, TOA, so opposite over adjacent is -1 over 1, which is still just -1. And then finally, cotangent is the reciprocal, bless you, which would also be -1. Okay? So that's how you do it. All right. Let's do, yeah.
Why'd you say that they don't always, the prime doesn't always equal the regular one?
Well, because like if I think of this as sine of 45 degrees, well, the sine of 45 degrees is rad 2 over 2. Because 45 degrees is really this angle right here. I have to think of this as this is the sine of 45 degrees, but in quadrant 1, so I need to make sure that I put a negative sign on it. Because sine is negative in quadrant 4. So, I mean, you can think of it as, okay, I'm just evaluating the sine of 45, but I need to do the right sign, plus or minus, not sine, S-I-N-E. All right, let's try another one. Number 2. Now let's evaluate, and we'll just do it like, we're not going to do all 6 every single time. Let's evaluate the sine of -120 degrees. Okay, these are all done without a calculator. So, to draw a picture is really good here. Let's do -120 degrees. So where is -120 degrees? It would be in quadrant 3. because we're going negative, right?
Yeah.
Okay. And then this angle in here, the reference angle in here would be 60 degrees. Now, you're going to see these all the time, these 60, 30, 45. Those are just the ones we always do. We're going to learn unit circle where they're on there too. So that's 60 and this is 30. Okay, so how are we going to set up this triangle? Across from 30 is 1. The hypotenuse is 2. And then across from 60 is rad 3. Is that right?
I don't know, were this provided or are we just?
Well, yeah.
30, 60.
That's your 30, 60, 90. Yeah, that's right. So you gotta know those. But the thing is, we're in quadrant 3, so you need to put negatives there.
Why not
Okay.
the hypotenuse?
Hypotenuse is never going to be negative
Okay.
because hypotenuse is a distance out to this point out here. Okay. Now, if you forgot that and you're evaluating the sine of 60 and the sine of 60 is opposite over hypotenuse, so rad 3 over 2. Let's say you forgot to put a negative there in your triangle because that happens all the time. You know, we're not used to negative sides of a triangle. You can remember that, you know, we're in quadrant 3 now. And in quadrant 3, only tangent is positive. So you would want to just put a negative symbol there if you don't remember. Okay? Erase it.
Is that more work?
Oh, it's freezing in here. Oh, Nick, it's freezing in here.
Is that more work?
I don't know. It just depends. It's a personal preference. I'd rather put, like I'm in quadrant 3. I know both x and y are negative. I don't know. It's up to you. All right, let's try another one. Tangent.
Isn't this number 2?
No.
Oh, might be.
I called that number 1.
Yeah.
Yeah. Let's evaluate the tangent of 5 pi over 3. All right, are you comfortable with radians yet? Or not quite? Almost? Okay, this is the way I think of this in my mind. 5 pi over 3 is almost 6 pi over 3, which is 2 pi. Okay? Yeah, so 5 pi over 3 is almost a full circle. We're just 1/3 of a pi short of a whole 2 pi. Okay? So I would draw my angle over here. I would drop a perpendicular. This reference angle inside of here is going to be pi over 3. And I know that pi over 3 is the same thing as 60 degrees. Okay, remember that. Pi over 6 is the same thing as 30. So if this is 60 degrees, across from 60 degrees, we just did this. What's across from 60 degrees?
30.
Rad 3? Oh, yeah, the angle is 30. So rad 3 is over here. 1 and 2. You're going to get very familiar with that. Okay? But rad 3 needs to be negative. Okay? Because we're dropping down here. It's a negative side. So when I evaluate the tangent of 5 pi over 3, I would do opposite over hypotenuse. And if you forgot to put the negative symbol, you would write rad 3, which is not going to be right. But know that you're in quadrant 4, and tangent's always negative in quadrant 4. And that would be your answer. Okay?
What's that 6 pi in the right hand?
Right here?
Upper right hand corner.
Oh, that was me telling you like how to get to 5 pi over 3. This is the way I look at it. See, some people like to go 1/3 of pi, 2/3 of pi, 3, you know, like they like to count it all the way around. I just think that's too much. I like to think of 6 pi over 3 is 2 pi, which is all the way around, but I only have 5/3 of a pi, so I'm 1/3 short of that to try and get where the angle is. All right, how about, let's do number 4. And this is what we're going to do for the next couple of days, just evaluate trig angles. We're going to get the unit circle, which, I don't know, some people like that better, but you'll have options, which is nice. Let's evaluate the tangent of 3 pi. All right, these ones are a little different, okay? Tangent of 3 pi. So we're going to go 1 pi, 2 pi, 3 pi. What happens is you can't make a triangle here, okay? So what you want to do with this, to evaluate the tangent of 3 pi, you want to just label that point. Okay, and what we do with that is we just label that point as -1, 0.
Is it always like 1? Is it always -1? Unless like you're on the other side.
It could be any number. It really doesn't matter. Yeah, it could be way out here at 5, like the point could be 5, 1, or negative. Yeah, it won't matter because when we evaluate the tangent of 3 pi, remember tangent, what we did way at the beginning, tangent is what? It's y over x. Okay? So let's go over here, and this tangent of 3 pi is going to be y over x. 0 over who cares? That could be -1, it could be -5, it could be whatever, right? So what's 0 divided by any number? It's 0. Yeah?
Where did you get the point from?
I just kind of made it up. Unit circle is that's going to be the point, but you could have chosen any point you wanted to over here. Let's say that you went around 3 pi and you chose that point to be -4, 0. And if you did that, you would still have 0 over -4, which is still 0.
Is there any time where you can land on the y-axis?
Yes. We'll do one of those too. Yeah. And then cotangent of 3 pi, what's the reciprocal of 0? Undefined. It's undefined. You can either write that, or you can actually write the word it's undefined. Okay, so let's do one where you actually land on the y-axis. Let's find the sine of pi over 2. Find the sine of pi over 2. These ones are special. They're the ones that end up on the x or y axis. You can't make a triangle out of that. There's no reference angle because you're not inside of a quadrant. So if you do the sine of pi over 2, earlier I told you that sine is is y over r. Okay? And so if you go to here, and this is pi over 2. Okay, and what point would that be? Well, what we just do, we make it easy on ourselves. That's the point 0, 1. Okay?
This wasn't the homework.
Yeah. So what you want to do is y, what's y in this case? It's 1. What's the distance from here to there? It's also 1. And so your answer is 1.
What's the R stand for again?
R is going to be the square root of x squared plus y squared. It's the distance of whatever point this is to the origin. R is the square root of x squared plus y squared. It's the distance to the origin. If we said, okay, why did I make that point 0, 1? What if that point was 0, 4? 1, 2. It doesn't matter, right? You go to there, and then sine would be, sine of pi over 2 would be y over r. Y is 4, but r is now 4. So you still get 1. It doesn't matter. Just make them all 1s. It's easier that way, okay? All right, the other type of question that you're going to get in tonight's homework, number 6, would be to have trig ratios, okay? So let's go ahead and find the cosine of theta given that the sine of theta is equal to 3/7, and they tell us that the tangent of theta is less than 0. Okay, let me explain this problem. We've already done one like this, but it was in quadrant 1. Okay? So sine of theta equals 3/7. There's actually 2 places you can have an angle that's equal to 3/7 for sine. 3/7 is a positive number. So I could be over here in quadrant 1, or I could be in quadrant 2. But they tell me this extra piece of information, that tangent is negative. Okay? So where is sine positive, but tangent is negative? Where is that? Quadrant, all saints trust Christ, is quadrant 2. Sine is positive. This is a positive chart. Okay, this tells you where everything is positive. So where is sine positive but tangent is negative? Well, it's not here. They're all positive there. Sine's not positive over there. Tangent's positive there. The only place you can be is in quadrant 2. Okay, that's why they have to tell you this. Or else you're just in quadrant 1 all the time. All right, so we go over here and we draw a triangle and we use this reference angle right there. And sine of theta, or theta prime, it doesn't matter, is equal to 3/7 would be opposite hypotenuse. And then be careful to look at your triangle and ask yourself, well, should this side be positive? Yes. Should that side be positive? Yeah, the hypotenuse is always positive. And then let's go ahead and find out what the adjacent side is by using the Pythagorean Theorem. What is it, rad 40? 7 squared minus 9 squared, rad 40, which is 2 rad 10. But what is it? It's negative.
Oh, because
Yeah, 3 squared plus, we'll call it b squared equals 7 squared.
yeah.
Okay.
I was confused.
Yeah. And then you get 2 rad 10. But it's negative, isn't it? That's you gotta be careful. It's going in this direction. Okay? The x is negative over here. And now we have to evaluate the cosine of theta.
And the hypotenuse is never negative.
Never negative, exactly. Hypotenuse is always positive. It's the square root of, positive number. Okay, so cosine would be then adjacent over hypotenuse. And that would be your answer. Now, if you forgot to write that that was a negative side, which a lot of people do, that's the most common mistake in these. You know that you're in quadrant 2. Is cosine supposed to be positive or negative in quadrant 2? It's negative. So if you forgot, just remember to look back and go, did I get the right sign? S-I-G-N, sign. All right, let's do, what was I going to say? Another one, number 7. Last one. Or no, 2 more. Oh, boo. Secant of theta is equal to 3. And the sine of theta is positive. And we need to find tangent of theta this time. Okay? So they're going to give you, it's like clues, they're going to give you some information that they need to give you, and then you're going to find out what one of the other trig functions is. Sometimes they ask you for 2. In this case, I'm just asking for 1. All right, so secant. Nobody likes secant. Nobody. Okay? The reciprocal functions, nobody really likes them. So what you can do is you can rewrite this. Instead of secant, I'm more familiar and more comfortable with cosine. So if secant is 3, what would cosine be? 1 over 3. Yes, it's the reciprocal. Okay? So just do that. I do that every time. If you're comfortable with secant, that's fine. Now, who knows what quadrant we're in? Yes. Cosine is positive, and so is sine. And when you have two or more trig functions that are positive that aren't reciprocals of each other, you're going to be in quadrant 1. That's the only place that cosine and sine are both positive at the same time. All right, so here's theta. Cosine is 1/3, so cosine is adjacent over hypotenuse. And now I need to find out what the tangent of theta is. Well, here's theta. Tangent is opposite over adjacent, so I need that opposite side. What is that opposite side? 3? Let's see. 1 squared plus a squared equals 3 squared. Rad 8? Yeah. 2 rad 2. That seems like an easy step, but you can make mistakes on there, so be careful. 2 rad 2. Okay, now we're ready to evaluate the tangent of theta. So tangent of theta is opposite over adjacent, so tangent of theta would be 2 rad 2. What did I do there? There we go. And one more. Yes, last one. Okay, you know how I said that some of our trig functions are undefined? Well, what happens when they're undefined and you have to find a different one? So, for example, let's say that the cotangent of theta is undefined. And secant of theta is less than 0. We need to go ahead and find out where we're at. All right. So this brings us back to that first triangle that I said. Cotangent of theta is x over y. Do you agree with that? If you look back at your notes, maybe. So it's undefined when y equals what? 0. It's undefined when y equals 0. Now, y is 0 in 2 spots on this. Y is 0 here. Y is 0 there. Secant is negative. They're all going to be positive over here, so I got to go with this one. What you can do is you can just label this as the point, negative 1, 0. That's going to be our point tomorrow for sure anyways. So just label it as negative 1, 0. And if you were to take the cotangent of this, it would be 0 over negative 1, which is undefined. So what's the secant of that? Well, the secant is r over y. No, dang it, x. Sorry. R over x. Did you look back at your notes? It is r over x, right? Yeah. Yeah, it's r over x. Okay, right. All right, so then what you get is what's the distance of r? Distance of r is 1.
Wait, isn't r the hypotenuse?
Yes. It's also the distance from 0 to that point. R. You kind of think of it as the radius.
Yes.
Think of r as the radius. The radius is always going to be positive. So if I'm going from here to here, that's a distance of positive 1. Or you think of it as r equals the square root of negative 1 squared plus 0 squared, which is 1. All right, and then what's x in this case? X is negative 1. So what's the secant of theta? Negative 1. Those are going to be the trickier ones, the special ones that are on those. But tomorrow when you do the unit circle, they're going to be a little bit easier to manage, okay?